Assalamu alaikum students. Today we are going to discuss the topic uh, fit a curve to the data. What is a straight line? What is a straight line? It is a first degree equation. Now what is a first degree equation? The maximum power of the variable is 1. The variable should be dependent variable or independent variable. Here we are discussing the independent variable x, which makes a straight line. If an equation has degree 1, means first degree equation, then we say the line created by the equation will be straight line, while the curve is a second degree equation, means that the maximum power of the variable is 2. It is also called the quadratic equation. You know the formula of quadratic equation. eh? I can write it for you. uh, a x square plus bx plus c is equal to 0. Now, this is the second degree equation. Now you can see that the highest power of the variable is 2. So it is a second degree equation. Okay, the maximum power of the variable is 2, which makes a curve with single band like this. This is a single band. The third degree equation is the one with 3 degree equation. Sorry, 3 degree, this is repetition of the word, so we can say that a cubic equation, this third degree cubic, C U B I C, cubic equation is the one with third degree equation. That is, the maximum power of the variable is 3, which makes the curve with two bands like this. uh, No, first band is like here, and the second band is here. This is two. These are two bands. The line representing cubic equation: a x power 3 plus bx power 2 plus cx power 1 plus d equal to 0. Now you can understand. I think I have explained the curve, which is what is the curve, and for which curve which degree equation can be used. For straight line we use first degree equation, and for curve with two bands we use second degree equation, and for one band we use second degree equation, which is also called parabola equation, and for the curve with two bands we use third degree equation, which I write it like here. Now we will move to our next slide. Here I also explained uh, by by a figure what is the first degree equation. I already explained that first degree polynomial or first degree equation, the highest power of the independent variable is 1 here. Yeah? Straight line with no peaks and no valleys, often written as this. It can be written as this. So this is the straight line. Now we can see the second degree polynomial, which is also called second degree equation or parabola. curved line with only one peak or one bend or one valley. It is also called one valley. This curve is like this. Now we are going to see third degree equation. It is also called cubic equation or third degree parabola, where the highest power of the variable is 3, and there are 4 constants in the equation, curve with the multiple peaks and valleys. So I think we can see that straight line has a uh, first degree polynomial and second degree polynomial and third degree polynomial. If you have any questions, then you can ask in the comments, please. Let's go to our next slide. Now, here is the data. Years and index of wholesale prices. Index of wholesale prices. Now we have 1, 2, 3, 4, 5, 6, 7, and 8 years of data, and we have to fit a second degree parabola. Uh, the equation with the highest power 2 and the line with the single band or one valley. Now we will go to our next slide. Here I write the equation y is equal to a plus bx plus cx power 2. It is also called second degree parabola. This is parabola. Second degree equation is second degree polynomial or parabola. Quadratic equation. These are the names of the second degree equation, where a, b, and c are constants to be estimated by the method of least square. Okay, the method of least square is already discussed earlier. Here, A, B, and C are constant, but unfortunately there are no formulas to estimate A, B, and C. So we have to use the normal equations of this equation, which are, so there are 3 parameters. So we have to use 3 normal equations like this. First we multiplied the main equation with the summation sigma. Then for second normal equation, we multiplied the main equation with the summation x, and for third normal equation we multiplied our main model, which is this one, with the summation x, and we can obtain this normal equation 1, 2, 3. Now we'll go to the next slide. Here, the key is to code the variable x like this, that we have a summation x is equal to 0. If you manage to do that, your calculation will be easy, because summation x is equal to 0 here, and summation x power 3 is equal to 0 here. You can see that, and the 2 summation will vanish in the previous slide. Uh, so there are some necessary calculations and summation which are going to use in the solution of the normal equations. Here trend is empty. In the next slide, maybe I will show how to use the estimated equation to estimate trend, but here we calculated the totals. Summation y is equal to 1 to 19, and summation xy you can use calculator or excel to compute these summations. We will go to the next slide. Now here you can see that submitting the summations we have in the normal equation 1 and 2 and 3, 1, 2, 3. Now you can see that in the normal equation where summation x equal to 0, constant b is eliminated. Now in second equation there are two constant with summation x and summation x3, because summation x is equal to 0 and summation x3 is equal to 0, so constant a is eliminated and constant c is eliminated, and same in equation 3. Now from equation 2 we can estimate the value of y. So we divide the whole equation by 163, oh, sorry, 168. So we have estimated the value of b. Now we are left with a and c. To estimate values of a and c, we have two equations, equation 1 and equation 2. Now you can estimate the values of a and b by solving these two equations by any method. For example, cross multiplication method, formula method, substitution method. There are a lot of methods. Cramer method is also available. Uh, Now we will go to next slide. Here I have also explained the cross multiplication method. This is the cross multiplication method. This is an example not related to our question, but the method is related to our question because I have used cross multiplication method. Okay. Yeah, I think you already know the cross multiplication method because you have learned the course of algebra and mathematics by Mr. Rauf Saab. He is your professor. So I think you already know the method. So I am not going to explain this method because it will take a lot of time. So next to the I have estimated the value of A. This is A, this is B, this is C. Uh, so we are going to do? We are going to estimate the trend. In the previous slide, I left the column trend, which is shown here in this slide. So in this equation, where sorry, this is misprinting, this is not C, this is the X. Okay, this is not C, this is misprinting. So for first value of Y there is a code X is equal to 7, so we put X is equal to 7 at here, 7 here, and X square minus 7 square, this is minus 7, and we are going to obtain the value this. So we repeated this procedure by different values of x and we find different values of y. It is noted that these values of y are estimated and these are average values of y. Okay, so we plot our data of these estimated trend line and we got this shape. This is a curved shape. This is not straight line. If straight line will be like this, sorry, I have done it manually, it should be like this and this. Okay, now you have learned how to fit a second degree parabola for a given data, which is our today's topic. Thank you.